Hello everyone, my name is Edwin van Dijk, your host of today, and I'd like to thank you for attending our webinar, Sitech's Industrial Analytics Journey. Our presenter today is Mark Pijpers, Principal Process Control Engineer at Sitech. Mark Pijpers has over 15 years experience in the field of process control, as well as in designing and implementing basic and advanced process control solutions. Over the last 2 years, Mark's activities have extended to analytics, where he's supporting predictive maintenance and operations improvement projects. Mark is an evangelist for using data analytics in the process industry and likes to help manufacturers get more from their data. At Sitech, Mark does that for companies at the Camelot site, but Mark also presents at various events, such as the recent ASC Forum in Barcelona, where he shared his insights and approaches for making industrial analytics successful in process manufacturing companies. In today's webinar, Mark will share his experience with you, the approaches, the failures, the lessons learned, and of course, the successes. Within the presentation, there are 2 poll questions, and we kindly ask you to participate, as we will directly show you the results, and it will help Mark to better tailor his presentation to your experience. At the end of the webinar, there will be time for questions. But before we begin, a little bit of housekeeping. I want to let you know that you are all in listen-only mode. So please make note of any questions you have during the webinar as we go along, and at the end of the presentation, you can type the questions in the GoToWebinar question box, which I will read out loud for Mark to answer. Additionally, all those attending today will receive a thank you email from us later this week with a link to the recorded version of this webinar. During the webinar, we will try to make the presentation as a PDF version available in the handout section of the GoToWebinar session. So with that, Mark, you can start whenever you are ready.
Hello, everybody, and good afternoon. So thank you, Edwin, for this introduction. This is just a little bit of my background, but Edwin already mentioned the majority of it. Except for one thing, at the bottom of this slide, if you want to contact me or want to contact Sitech, later on we will give you the presentation as a handout. So here are my email address and our company's website. So this presentation is about a couple of things about our journey in analytics. But first of all, I want to start off with explaining you a little bit about Sitech for those of you who are unfamiliar with our company. We take you on our journey that started a couple of years ago, and we will present some use cases that were very successful using TrendMiner, and closing off this presentation with some thoughts. As Edwin already explained, we will give some questions to you as well, and at the end of the presentation, it's for you also the opportunity to ask more questions. So, starting off, who is Sitech? Sitech is actually a company that is very young in age. It started off a couple of years ago as part of a big reorganization in the southern part of the Netherlands, where there's a big site called Camelot, and that used to be 100% owned site by DSM. And DSM started their own journey and started selling off their traditional industry assets at the Camelot site to new end users. And with that, also Sitech was founded. We are an organization with approximately 720 employees, and we provide maintenance, improvement, and control services to our shareholders and our customers. Well, for those of you who are not familiar with the Camelot site in the Netherlands, it's located in the south near Maastricht. And on the right side of this slide, you can see all our customers and shareholders on this site. And yes, of course, DSM is still a part of the site, but also new entities like Arlanxeo, Ancor, Fibrant, Ocean Nitrogen, and Borealis. So, our journey started a couple of years ago. The journey was about, can we use analytics to take a next step in optimizing our processes and our assets. And with that, we started a new way. Analytics had to be in our genes, and for that we wanted to create a digital and innovative culture. At the same time, approximately 2 years ago, there was a new Center for Asset Health founded. It's called the Sitech Asset Health Center, and its objective is actually to predict the performance and conditions of our assets, and to be able to anticipate in a predictive mode when these assets will fail, or actually when they need to be maintained before they fail, so we can have zero surprises in unplanned downtime. So this can only happen if you use the technology that is out there today, because you need to predict using advanced analytics combined with measurements when and what will happen. So a little overview. Technology that we used today that was not there before is wireless measurements, all kinds of measurements that use advanced technology embedded in the measurements, but also are used as a basis for advanced analytics. And together we basically optimize our whole infrastructure to use wireless communication with sensors, but also wireless communication using tablets, to be able to combine each of these individual data sources to combine with an asset to a dashboard, and use that for monitoring and be able to anticipate upon potential failures. So our data journey. So if we look at our site, we are at the chemical process industry part of the spectrum, and that is shown here in this slide by the manufacturing on the left side. What it actually says is that the chemical processing industry is the proud owner of the most data points in the world. So maybe you thought Google or Amazon were the big owners of the data. Actually, the chemical processing industry is the big owner. But also, we are at the bottom end of translating that data into actionable information. So at the other side of the spectrum, yes, of course, you can find the retails, like as I already mentioned, the Googles and the Amazon, who have been playing this big data analytics for years now, very, very successfully. In the manufacturing environment, we're just starting compared to those guys. So now, Edwin, it's up to you to launch a poll question. So the question is, what is your biggest analytics hurdle? And you can find that in your poll section on the GoToWebinar, or you can see it. And I would like to invite you to select one of the answers that are shown below. So we're just about to close the poll. So a couple of seconds remaining before we close it. Okay, so what we see in the poll question now, the response is that it's a bit of a break-even between unclear economical benefits, insufficient embedding of analytics in the work processes, and improper tools. Closely followed by insufficient analytics knowledge and insufficient management support. So you see, of all of these answers, you have to play a part of it. So it's not about just IT, it's not about software, it's not about analytical skills, it's also about the people and the whole culture around it. And that's also all of these aspects is what we saw when we started our journey as well. So in this particular slide, you will see a 5-step approach when you do solve any case using analytics in general. When you want to solve a problem using data, the first thing you need to do is get the data and then prepare it, clean it, get rid of all the non-relevant stuff, translate it in and transform it into some kind of graph or visualization that it tells you a story. Then you start diving into the details, doing analytics, and in the end you come up with an answer. And what we saw is that actually 80% of the time of an engineer is typically spent in the first 3 steps, which means that in the end he only has 20%, and sometimes even 20% is a bit optimistic, to do the real stuff that has the added value. It is very labor intensive from data acquisition to visualization, even though most of us stretch Excel to its limits. It takes a lot of time to go through these steps. Whereas the actual value of a process engineer is in the last 2 steps. But how many of you haven't encountered the situation that you are asked to solve a critical problem with a time pressure on it, and you just can't get around it because the first 3 steps take too much of your time? Now, you all heard about data scientists and about this new thing called machine learning that will solve all your problems. Actually, machine learning is a very powerful tool or technology, whatever you want to call it, out there, but it creates its own problems. Just using advanced analytics, throw it at the data, you get an answer, it would solve all your problems. It's not just that easy. So what you need is actually 3 ingredients to solve a problem. You need hacking skills. And why do you need hacking skills? Hacking skills in this particular case does not mean break into your computer, but means more that you have to get the data fast. And sometimes you need to do something to get that data. You need to have math and statistics skills in order to use these analytics. But in the end, that is transforming the data into some kind of answer, but you need to be able to understand that answer. And the only way to do that is you need to have subject matter knowledge, because the answer has to have some kind of contextualization before anybody will react upon it. If you give the answer or the question to a statistician and he will just come back to you, I did a hypothesis test, and the answer is that P is less than 0.05 means it is statistically significant. As a process engineer, probably that won't mean anything to you, because you look at an XY plot, you see a cloud of dots, you see a cloud of dots, and you're not really convinced. So that is also what's happening when you try to combine these 3 ingredients using 3 different people. They talk different languages. So overcoming this language barrier is an additional challenge. So the way we try to solve it is to look actually at, okay, can we make use of these advanced analytics without trying to train all our process engineers and process control engineers to become a data scientist? By the way, for those of you who are a bit familiar about a data scientist education, it takes about roughly 4 years of university. So we are talking about people involved full-time in a daily job, and next to it they have to do a very complex study. So that's one way of doing it. The second way of doing it is you get a bunch of people into your organization that are skilled in data science. Data scientist is actually one of the sexiest jobs out there nowadays. And even if you're lucky to find those people, a lot of them you will lose in a very short time because they're going to work for Google, Amazon, and the likes. So it doesn't mean that they're not out there, but it's difficult to grasp. And even data science, you cannot just hire one person into your organization because it's so broad area of expertise. You talk about all kinds of mathematical skills, all kinds of statistic skills. This person needs to fall back onto colleagues who cover the whole spectrum. So just getting this one person to your organization is going to have a very a field day in helping. And then, of course, you get the time lag issue. You're, as a process engineer, want to solve a problem now. If you want to make an appointment with this person and he is available to you in 2 weeks' time, it may be too late. So all kinds of organizational issues. Doesn't mean that these people are not valuable to our organization. They definitely are. And we also work together with data scientists, but it's a matter of if we can put these analytic skills into the hands of the subject matter experts, being the process engineers and control engineers, they can do the problem solving themselves. They can analyze. Because what happens when you do a problem analysis, you ask a question to the data. You get an answer. That answer gives you some insight, but most of the time also triggers a new question. So think about it when you have to work together with people, asking one question, a couple of days later you get an answer back, asking another question, getting another answer back. So that's why we're investigating, can we stretch that self-service analytics space as much as possible and leave the very complicated problems to solve together with those data scientists. Now, it sounds easy, it's not. And it starts by realizing that this whole big data analytics is a journey. You cannot write a specification what you want. At least I haven't met anybody yet that can give me a clear answer. This is what you need. And even if you look out there to all the software solutions, they are growing exponentially. That means everybody is trying to find a pot of gold in the analytics sphere, but it's not, you can buy not one single solution out there that solves all your problems, and that's what also makes it interesting, because you don't know what you want up front. You have to learn, you have to adapt, and that doesn't mean just buying a software and buying a new piece of software. It's not that easy. You also have to change the way you use software, the way you do analytics, the way you use math and science and statistics, and also the way you handle your data. Because the data has been there for many, many years, but the data was originally, or the IT infrastructure that was set up in the first place 10 years ago was set up with a whole different perspective than nowadays. So that means when you start this journey, you also have to reconsider, rethink what data do you store and in what quality, etc., etc. So you can do things. You can start a very big project and ask for a very substantial sum of money to decision-making units. And then the first thing they ask you is, what is the business case? Now, you can read all the articles in the world. The pot of gold is big, but try to translate that back into your own organization. That's not so easy. So the best way, what we found out throughout the years, is you start a pilot. You have some ideas. You have found a software provider or solutions provider that is willing and to help you in solving the problem that you try to handle in the pilot. And then you try to answer two questions. The proof of product question, is the product of this supplier capable of handling my problems? And also proof of concept, is it this way of thinking, analytics thinking, is that suitable for our organization, and does it bring me added value? And throughout that course, you learn and adapt. So we started a pilot with TrendMiner, which is a Belgium-based company. Maybe some of you know them, maybe not. They used to have a different name. The name was D-Square, but nowadays they are named TrendMiner. And that is also the name of their star product. And when we started with TrendMiner, we had some basic requirements. Because we could not write a specification, as I already mentioned before, it needs to have that mathematical skills, the software needs to do this and that, and so forth and so on. But at least we knew that when we started, it needed to be easy to use, because whatever piece of software you introduce into your organization, if it's too complicated and too difficult to use, 99% of these solutions will fail in your organization because it takes too much time, too much training for the people to get to know it. It needs to be a time saver. So in the end, people need to like it. So how do you measure time saving? That you can make it very difficult, but the easiest way is to just ask people who work with it, does it help you? Were you able to solve your problems in a shorter amount of time, yes or no? Seamless integration with your IT landscape, which is very important because you need those 5 steps that I just mentioned earlier. You want to skip as many of those steps because a lot of these steps you can automate. So you need to have, so TrendMiner needed to be able to talk to our data and not just use Excel as an intermediate and then do data dump into Excel and then import it into TrendMiner. That would not have been very efficient. It needed to create value. So how do you do value creation using analytics? Is basically you are able to solve problems that you were not able to solve before. And the last one is a bit of a strange duck, but is a very important one. It needs the company need to provide you with effective and efficient support. So that for us was more than just having a support site where we can put in tickets if something doesn't work, and hopefully you get an answer within a period of a couple of days. That is actually hurting the chance of being successful with this pilot, because people will go back to their old tools that they have available. So ideally, we would like to have real-time support. And support meaning not just bug fixing, but also helping us solve problems when we get stuck ourselves, or and even helping us giving us the functionality that we need and that we learn that we need throughout the journey. So in short, summary, what TrendMiner actually is: it is a trending client, but it is a trending client on steroids. It has advanced pattern search capabilities using data from historians like OZSoftPy, AspenTech, IP21, and Honeywell PhD, Wonderware, what have you. It has a fast search, and you can actually overlay the results that you find. I will explain in the use cases later on what that actually means. Because if you want to search into your data, you need to be able to do it fast. The traditional way is, in your traditional trending clients, is just zoom in, zoom out, go back in time, scroll back, scroll forward, and spend a lot of time finding the sweet spot. And it has many more powerful features that can help you in these different analytics space, like descriptive, diagnostic, and predictive. And what that means, I will explain to you in the use cases. Now, as I said, we were trying to stretch that self-service analytics space as much as we can. And those popular terminologies like descriptive, diagnostic, predictive, and of course the holy grail prescriptive is a nice way of saying that you start with trying to explain what happened. The next thing you want to explain is, okay, why did it happen? If you know that, you can try to do countermeasures. You can try to predict next time it will happen. So you can try to prevent it and manipulate the influence so you can prevent it actually from happening. Now, where do we use TrendMiner, or where have we used TrendMiner throughout several use cases, is just to compare. Okay, we have a situation in a particular grade. Did we have that situation when we made the grade last time? Yes or no? Simple question like that. So the first thing you need to do when you want to solve such a question is find in your data when was the last time I produced that grade, and maybe the time before and so on and so on. And what happened with my reactor temperatures? What happened with my throughput? So those simple searches, and even in the root cause analysis sessions, when you want to solve a problem using a root cause analysis, the first question is you want to have an insight: what happened, and what were the leading events actually resulting in that undesired situation. And in some use cases, actually, our engineers, they started using TrendMiner as an interactive tool during the root cause analysis, solving or answering questions that traditionally were put on an action list that process engineers had to dive into with their traditional trending clients, trying to get an answer for the next root cause analysis session. So actually, they were able to solve those type of questions during the root cause analysis session and minimizing those action items, and actually able to solve root cause analysis faster than before. You can also use it for data cleaning for APC projects or Six Sigma projects. So if you have your big data space, meaning you have years of data, and you're only interested in what we call relevant data. So what you need to do is create a subset of that data. Now, in traditional APC, you're interested in when some variables change, where others remain constant. Now, try to solve that question using traditional trending clients. And even Excel, you can't just use filters in Excel, say, show me a part of the data space where variable 1 changes and variable 2 is constant. It's not easy. You can say larger than or less than, or you have to write all kinds of subroutines to say, okay, then I look for first order derivative changes and all kinds of fancy stuff. But then I think ultimately you're trying to recreate what TrendMiner can already do for you. And one interesting part is once you did a search and you find a recipe for that search, you can save actually that search and use it as a monitoring rule. And so the next time on Monday morning you go into your office, when you open TrendMiner, you can even see throughout the weekend if that particular event that you saved in your search actually occurred or not. So you don't have to repeat all your steps to find if the event occurred or not. You can actually save it as a search and it will tell you.
Okay.
So it's time for our second poll question. What are your main objectives in your organization when you start using industrial analytics? So is it because you want to reduce cost and waste? Is it because you want to improve product quality? If you want to increase your production yield, you want to do something about energy management or improve on energy management, or do you want to solve unsolved process questions? So I'm very interested to see what your response is. Okay, a couple of more seconds before we close the poll. Yep. Okay, so the solving unsolved process questions is number 1, closely followed by reducing costs and waste. Okay, let me see if I can give you a bit more insight how you can handle those two areas in the use cases that I'm going to present to you. So I have 3 use cases for you, and the first one is in the descriptive analytics space. And what you see on the right side is actually the trending part of TrendMiner, and it contains of two graphs. The top one is the short window, the short time window trends of your process variables, and the bottom one is the navigation bar where you can see all your data. Now, in the first case, there was a situation where we had a very high and actually a too high thermal stress due to fast cooling and heating of the reactor. when it and we didn't have a monitoring solution that actually sees and counts how many times this occurs. And you also see on the right side that these changes can be very fast, and the time that they take can vary. So the goal that we have as like a first exercise when we start using TrendMiner is how many thermal cycles result in a failure. Now, TrendMiner cannot tell you how many times it will result in failure, because that's where you need subject matter expertise with it. But what it can help you is getting an easy and quick answer in how many times did it occur. So if you can do that, and actually, as I mentioned before, use it as a monitoring and a notification system, you can set it up, look for it, and that's what we did actually. So what we did is it's an easy way to calculate the first order derivative and just count spikes. As easy as that. And we were able to do it for data of a 5-year period. And we just said search, just like Google, search how many times this spike occurred. And it's actually less than 5 minutes work. And what TrendMiner does, it gives you two things. It gives you an answer how many times, actually does a nice job of adding them to you, so you don't need to count them yourself. And it also gives you on the bottom part, and it's not so good to see in this graph because there were a lot of times that it occurred, but it actually gives you little blue bars showing you actually when it happened in time. So once you have those search results, as I mentioned, it gives you a number, but you can also, what you did actually is you created a subset of data. And that subset of data you can export to Excel to do more advanced analytics or special analytics if you want to do so. You can use that data to put in a Minitab or some kind of other advanced statistics tool, or maybe use R or Python or any of like. Or you can actually hook it into and send it to your subject matter expert to look at it. But you can also just as easily that search you created, you can actually share that search with your subject matter expert. So not just creating a JPEG of it and send it via email, say, hey, look, this is a JPEG, because what most of the time happens is that your subject matter expert wants to dive deeper into, okay, I want to do continue on that search. You can actually, your whole history of what you did coming up to this search result, you can actually share that as a URL to your subject matter expert, so he can continue with the search. So what we said is, as a little exercise, it took less than 5 minutes work, where in traditional trending clients it would take much longer, most of the time so long that you don't even start trying to solve these type of questions. So was, in this particular case, the question, were we able to have it as an efficient time-saving tool? I think the answer was definitely yes. So the second one is in the space of diagnostic analytics. And what we had was a situation where a chemical needed to be washed out. And every time or periodically we got this peak. And that is not a very wanted peak, because it can cause too high temperatures to a downstream process. So the washing unit uses steam to wash out this particular chemical. So the natural instinct is, okay, we need to increase our steam injection to be able to solve this problem. But what actually happened is, even though they increased the steam, the problem still remained. So then, of course, that is a break in your traditional process model in your mind. So you have to try to find out why. So the goal was to determine the root cause of this chemical peak, and actually, as a bonus, you gain more process knowledge once you're able to solve this particular question. So what we did is, actually, we did a search. we searched for those peaks, and we compared the results of operating periods. Now, what you see on the right side in the graph is actually a search, and we try to find similar situations. So we just say to the software, find similar situations. Find the pattern that you see in front of you, and you can overlay these results, and that's what is shown with the dotted lines. You can try, you can do overlays of one variable, or you can do it of multiple variables. And what happens then is it gives you a new picture. And then your subject matter expert brain starts thinking and saying, hey, if that's the case, then we could definitely maybe suffer from a particular influence. So what they were able to do is they actually were able to derive, using this search and visualization, to see that actually increasing steam did not have any effect at all. And that actually another process variable was the culprit. Now, where they were able to modify that process parameter by just changing the operating window, got a more stable production, a stable operation, and increased production, and reduced the amount of steam that they were adding. And what you see now is on the right side is when you want to see how with these overlays, if you have one variable, you can have a graphical overview. But if you have like 10 variables, it becomes difficult. And that's a bit similar when you use your traditional trending client. If you have 10 or 20 variables as a trend in your window, well, at least I cannot see a pattern anymore. So an alternative way in TrendMiner is to present those variables in a tabular way and compare them with some kind of statistics. So what you see here on the right side is we were able to compare all of these events that we found using, for example, the average value. And it gives you the differences between those events in time. And when you look at it together with the process engineer, even though it says here that there was some difference in pressure for the subject matter expert, and that's where the secret sauce is, that was actually a significant change. Even though if you look at it just from a statistics point of view, you see only plus 1%, and there were others that are much higher. But for the subject matter expert, that was actually a much more important variable. So they influenced it, they modified the operating window, and they were able to save 1.8 million euros. And the amount of time it took them was less than a day. So the last one is we have a lot of peaks in our use cases somehow. In this particular case, it is a product flow peak. What happens in certain situations, you get a product flow peak and your sensor saturates. And that's not so good because you use that for the measuring how much product you're actually producing. So you have a lot of manual corrections in your KPI reporting, a lot of labor-intensive manual changes. So are we able to prevent that by detecting what the root cause of these peaks are? So as I already explained before, what happens is you start asking a question to a software, you get an answer, and a lot of times it triggers a secondary question. And that's exactly what happened here. So what happens in a traditional workflow using TrendMiner is you start with the usual suspects that you think that have an influence on your peaks. And you try to compare certain different situations to actually see if it triggers one of them being actually the one that causes it. So what happens in this particular case, we call it a two-stage approach, is that of these limited first set of variables, we saw a significant change in one of the variables, but that was an intermediate variable. So we expanded then our search window to more variables, including into the search, and actually we found that in this particular case, we were running a unit at a too high level, causing a exceedings of the demister capacity. So this is a screenshot that was actually used during the search. So what you can do is you can say, okay, I have an influence. I have a path. I see an anomaly in my variable y. I have other variables that are potentially the candidate causing this influence on variable y, and it gives you two things. It gives you like a gain. And then in this particular case, for example, on the top one, you see minus 109 times P3. So it gives you like an effect of what is the effect of a certain pressure. But that's not the only thing. It also gives you a significance. So even though you can have a very high impact of a certain variable on your output variable, on your y variable, it doesn't tell you anything about the significance of that. And in this, and TrendMiner is able to give you also these significant numbers. So it's a bit like, yes, it tells you that there is a high correlation, but it also gives you, okay, it's not only highly correlated, but it also has a high influence. So the root cause was identified, again, together with that subject matter expert, creating a quick overview, getting new insights, and then together with subject matter experts able to derive the root cause. They were able to, again, improve the process insights and be able to reduce the manual labor because they were able to prevent those spikes. And as a bonus, also got improved process stability. And on this picture in the end is what you can see is the cause and effect, able to see that as a with overlays. What you also see there is the influencing factor actually increases and then decreases again. Let's say you would do a correlation analysis in a traditional way. You would use static correlation, and the only way to do that, filtering out the dynamics, is to average the numbers. So if you would average those pink lines, you would get a flat line, and you lose your complete correlation. And using these overlays together with the influence factors actually doesn't break the correlation. So, the closing thoughts. I hope I was able to demonstrate to you that our little pilot we did with TrendMiner was actually a success, a big success in such a way that the discussion should be continue to pilot and do a massive rollout of TrendMiner on our site was a very short discussion. So we saw it actually proven efficiency and value-adding tool for the subject matter expert. And for the process engineer, the process control engineer, it's actually a powerful tool. One of the little secrets of the success in the pilot I haven't mentioned yet was that when we introduced TrendMiner in the beginning, we gave people a basic training on how to use the software. And what happens in the beginning is you have to get to learn the new software. And like all our process engineers, we're very busy people. We simply don't have the time to get to know the software. If it takes too much time, you very quickly go back to your traditional way of working, like Excel and your traditional trending client, etc. So we realized that as well in our pilot, and what we said, we need like a floor walker. We need somebody who is able to think along with us in solving the cases. So he needs to be able to understand our process language. He needs to understand the application, and together with us, helping us improving solving cases using TrendMiner. So TrendMiner realized that, and they started a new service during our pilot, and it's called Process Engineer on Demand. So what it actually means is we get one of the guys from TrendMiner, who is a process engineer by nature, but is also an experienced TrendMiner user by nature, and he helps our process engineers solving cases together. So what you get is you have this person who is highly skilled in TrendMiner. He's not the guy doing the cases for you. He's the guy who's helping you solving the cases together. So you automatically are able to solve cases faster, but also shorten the learning curve for using the application. And in the end, getting our people up to speed much faster. So becoming process engineers on demand ourselves in terms of level of expertise using software like TrendMiner. So it is a very powerful tool, and we see it as a complementary tool to other analytic solutions that we are currently investigating. So with this little graph, I just want to quickly touch upon what I already mentioned. If you introduce new software in the beginning, you have some challenges to overcome the traditional boundaries and go back to your traditional tools. And those items are organization, technology, and data. And technology meaning we started very, very, very early with TrendMiner, and I have to say they made a significant evolution over the last year. If you look at their latest version compared to when we started, it is such a big improvement. And their slogan is joint innovation, and what I really appreciate is that they listen to the functionality that we need and they embed it in the software. They have real-time support. They have like a little chat box function. If you get stuck with a question or anything, you can just chat with them, so you don't have to wait until next day to continue your case. Data, improving quality and resolution. And what I mean by that is when you start doing these analytics cases, you also find out that sometimes you need to change your data in your historian. Higher frequencies, less compression, etc., etc. So automatically, as a bonus, you also rethink your whole data structure. And of course, completeness. So you realize that sometimes your tags are still in the DCS and are not stored in the historian. Organization. I think I covered that as well. The process engineer on demand really is for me was one of the key success factors for the pilot. Now, in the end, how can you benefit from our analytics journey except for this presentation? And I hope I gave you some new insights on some things to think about. I hope I was able to convey the message that I really am a strong believer in working together with data scientists, but I'm even more stronger believer in that you can really get successful in your organization using analytics if you're able to exploit the potential of self-service analytics. So self-service analytics is actually enabling you to analyze issues that are too complex using conventional tools. I think the use cases cover that. But it requires knowledge of the process and data analytics. Understanding the context is crucial. You have to understand the process. You have to understand what the data is telling you. And it enables gaining fast insight into issues and forces alternative thinking and doing root cause analysis. So how can we help you? You can benefit from our experience in this journey, so you don't fall into the same pitfalls or even accelerate your implementation of analytics or using our services and our skills and expertise from the Asset Health Center and industrial analytics. You can also, when you start a journey with TrendMiner, together with TrendMiner, we can help you in also doing the same key success factor implementation as we did using Process Engineer on Demand. And Sitech is actually offering the services together with TrendMiner to help you in that and getting up to speed as fast as possible. Minimizing the learning curve as much as possible and getting the value out there. So with that, I'm at the end of my presentation, and now it's time for the questions.
Yeah, thank you very much, Mark. It was a very nice overview. So again, for everybody, if you have questions that you wrote down during the entire presentation, please fill them in the question box, and then I can read them for Mark to answer. So while questions are coming in, I'll wait a little bit so that you have time to type them in the question box. So the first question coming in, so yeah, Mark, you discussed that there's also a change in what kind of data needs to be captured, but of course, throughout all these years, the number of, the amount of data is increasing, and how do you actually manage that at Sitech?
So data management is not an easy task. Traditionally, as I said, that when we look back when we first introduced historians on our site in the 90s, the primary objective was that we wanted to optimize our plans using long-term visions, like you wanted to look for years worth of data. Now, at some point of time, you start using analytics. Maybe you had a Six Sigma program in your organization as well. And then the first thing you start noticing is that you have a fair amount of compression in your data. And the problem with compression is it disrupts your correlation between your variables, and it also filters out other phenomena like dynamics. So we realized that already a couple of years ago, and we started to already improving our data resolution. Because the problem with that data is as soon as you realize it, you start changing it. But that means that the historical data before that point in time is not containing that information anymore. So what we try is optimize our historians, maximizing the amount of tags that you can have, because disk space is not as expensive anymore as it was in the 90s. And you have to realize that if you have the data, you can do something with it. But once you realize that you want the data and it's not out there because you somehow didn't store it, for whatever reason, yeah, you start at point zero. And you cannot do pattern search, or you cannot do any kind of empirical analytics if you don't have the data. So we continuously investigate opportunities and way of improving our data in our historians to start with. So maximizing the tags that we have from our DCS systems, but also we add more variables using wireless sensors, etc., and embed them into our historians. So one of the suggestions I can give is when you start implementing a historian into your organization, really think about the data that you want to store, and don't maximize the amount of tags, I would say, because you don't know when it will help you with solving any particular case. But realize if you need to solve a case and the data is not historically stored, you have nothing.
Okay, thank you. Another question coming in here. How does TrendMiner cope with interactions between multiple factors when looking for a link or correlation with the output variable? It's a question from Salvador.
Okay. So coping with multiple factors. TrendMiner uses this influence factor. So if you look at interactions between multiple factors, couple of tricks in the bag. As I showed you in the graph, you can do a comparison with several statistics from average to correlations, because one of the things you need to consider when you do an analytics case is you want to find the axis that influence the y, but you also are interested if the axis don't influence themselves amongst themselves. And TrendMiner has several tricks in the bag for that. Correlation is that they use advanced analytics that I was unfortunately not able to show you to compare all these events and all these variables. The influence factors, the pattern search, there is a huge amount of multivariate capability under the hood.
Okay, so another question here. If you look at the various use cases, then there are benefits in various areas, and it was pretty impressive to see 1.8 million as a saving because of one of the use cases. But from all those use cases, what is the most significant for your customers for the other sites at the Camelot site?
Okay, well, we talked about a couple of use cases. I can't answer the question by just saying, okay, we had even a case that was more than 1.8 million. We had a very interesting talk with one of the managers who actually was one of the decision-making units to decide if you would continue after the pilot with TrendMiner. I said, how do you motivate if you want to continue this journey with TrendMiner or not? And he had a very simple answer, but for me a very powerful and effective answer. He said, I want my process engineers telling me that they don't want to work without it anymore, that they're actually using it. So for me, if you want to talk about KPIs, it's just a matter of how much time do you spend using the software? And do you like using the software, and does it help you? And if the answer is yes, then I'm willing to invest in it.
So looking at the time, there's not much time left for more questions. So here's another one. Does Camelot has used TrendMiner on batch profile data, and how this is set up?
Good question. We have used it on data from batch and on and on polymer plants. The interesting thing is, you can compare grades or runs or batches in several ways. So traditionally, you had to program triggers in your control system or historian that would tell you when a batch starts and when a batch ends. In TrendMiner, it's actually much easier to do because you can search when grade A goes to grade B. Simple as that. You don't need to configure the trigger for that. You just search in the data. You can search for a pattern like a step in your temperatures. You can even, but that depends on your historian, use digital tags, as we call it, like discrete tags, to see if you go from one grade to the other, and you can just search for it. So search capabilities in TrendMiner are not just about find me the data when value X is bigger than Y, but you can even zoom into a certain pattern like a temperature shape and just search, or grade A to grade B, and just say search whenever that happened. So that's the very quick way of finding the batches. And then the next thing you can do is overlay those temperatures and compare different runs or different times you created the same grade or batch.
Okay, thank you, Mark. Yeah, given the time, I think this is the last question. So what would be your next step in using analytics in your organization?
So the next step is, I think, a continuation of what we're already doing from the Asset Health Center. Is you start the basic approach is you start from a reactive point of view. So you start doing analytics after something happened, and what we see more and more is going to the predictive mode, monitoring, fingerprinting, anomaly detection. So you're capable in detecting much faster that something is occurring without the actual problem having been occurred. In different spaces, in the asset space, we're trying to predict and monitor if an asset breaks before it actually does, or fouls, like a heat exchanger or a rotating equipment. And from a process point of view, we're trying to monitor and predict and fingerprint that we're still in the optimal operating window, or that we are deviating without actually touching an alarm. So I think we're going more into the predictive monitoring, fingerprinting mode, whatever you want to call it. So from reactive to proactive and predictive. That is, I think, the trend.
Okay, thank you. So with closing the webinar, a last one that quickly came in. So what would be your net promoter score for TrendMiner? So would you recommend TrendMiner to any other customers here in the audience?
let's see how to answer that question. I would say I hope my enthusiasm from the journey that I gave during this presentation answers that question. So the answer is simply yes.
Thank you very much. So thank you everybody for attending the webinar. With that, I would like to invite you to watch out for our next webinar, which is on the 18th of July, about how to become successful with using TrendMiner in your organization. Thank you very much and have a great day.